Okay, picture this. It's January 2004. Millions of miles away on the surface of Mars, NASA's Spirit rover is kicking up red dust. It's a huge moment for science. But back here on Earth, on a little corner of the internet, a single question is about to spark a massive debate among programmers all over the world.
It all started with this, a post from a user named Dalibor Herg. It seems innocent enough, right? He was just wondering if NASA could use the programming language, Java, to create some cool 3D models of the rover's journey. But that one little thought ballooned into a much, much bigger question. Could Java actually be running the entire show up there on Mars?
So what was the real deal? Was this incredibly expensive, mission-critical robot really being steered by the same kind of code that used to run little animations on websites? Well, today we're going to play detective. We're going to dive into the arguments, get to know the tech, and uncover the truth behind the Mars rover's secret code. All right, to crack this case, we have to start with our main suspect. Before we can figure out if Java was the right stuff for a trip to Mars, we need to answer a more fundamental question. What is Java, anyway?
At its heart, Java is just a tool that lets people build applications. But it was created back in the 90s with this revolutionary idea, a motto: write once, run anywhere. The dream was to build one universal language that could work on literally any device, your web browser, your phone, even smart cards, without having to rewrite the code every single time.
And trust me, when they said anywhere, they meant it. Java isn't some obscure language only a few people use. It's the powerhouse behind tons of the Android apps on your phone. It runs the massive servers that stream your Netflix shows. It helps process your banking transactions. It's the language that built the world of Minecraft. It even runs the national health card system for the entire nation of Brazil. Java is, without a doubt, a huge deal.
And that brings us right back to our Mars mystery. You see, the programmers in that 2004 forum weren't just arguing for fun. Their whole debate really boiled down to just a few of Java's most important and, as it turns out, most controversial features. So let's break down what they were fighting about. So, the first big showdown was all about speed. You had one user, Jan, who did not mince words, claiming nothing is slower than Java. But on the other side, you had Ken, who argued that modern Java was just as speedy as other high-performance languages. So, who was telling the truth?
Well, it turns out they were both kind of right. See, the earliest versions of Java were pretty slow, but by 2004, it had a secret weapon under the hood called the Hotspot Optimizer. The best way to think about it is like an engine that tunes itself while you're driving. As a Java program runs, Hotspot finds the busiest parts of the code, the hotspots, and makes them faster on the fly. So the speed debate was a lot more complicated than it looked.
But speed wasn't even the biggest issue. The most critical argument, the real showstopper, came from a user named Tony Hill. He pointed out that Java just wasn't built for real-time systems. Now, a real-time system is one where things don't just have to be correct. They have to be correct on time every single time down to the millisecond. If a rover is driving towards a cliff, even a tiny unexpected pause could be, catastrophic.
And this led to maybe the best comment in the whole discussion. When the Spirit rover started having some technical problems, a user named Joe joked, "Are they sure it's not just Sun's JVM taking a break to do a GC?" Now, it's a funny line, but it points to the single biggest reason Java probably wasn't driving that rover, something called garbage collection.
So what on earth is garbage collection? Well, in a lot of programming languages, the programmer has to manage the computer's memory by hand. If you forget to clean up after yourself, your program can crash. Java made this way easier with automatic garbage collection. It's like having a little robot janitor inside your program that automatically tidies up memory you're not using anymore. It's a lifesaver for most apps. But here's the catch. You can't control when the janitor decides to take out the trash. And on Mars, you can't afford a random pause for cleanup.
Now, with all that said, there was still a really good reason why someone might want to use Java on a project as complex as a Mars mission. And it all comes down to its biggest, most important feature, the Java Virtual Machine, or JVM for short.
The entire promise of Java, its whole reason for being, is this idea of platform independence. It's that write once, run anywhere slogan we talked about. Just imagine writing a program on your Windows laptop and then having it run perfectly on a Mac or a big Linux server or even a phone without changing a single line of code. That was the game-changing problem Java set out to solve.
So how does it pull off this magic trick? It's actually a really clever three-step process. First, the programmer writes the code. Easy enough. Second, a tool called a compiler turns that code into a universal format called bytecode. And this is the secret sauce. This bytecode isn't for Windows or Mac, it's for a made-up computer, the Java computer. Finally, the Java virtual machine on the actual device acts as a translator, turning that universal bytecode into instructions that specific machine can understand.
So yeah, the JVM is the magic ingredient. It's like having a universal translator for your code, letting any computer understand it as long as it has a JVM installed. This portability is Java's absolute superpower.
Okay, so we've heard the arguments. On one hand, Java is super portable and safe. On the other, it might be too unpredictable for real-time control of a rover. We've seen all the evidence from our internet detectives. I think it's time to deliver the verdict.
The million-dollar question, was the Spirit rover kicking up that red dust on Mars actually being controlled by Java?
And the answer is no. But also, yes. It's complicated. The rover itself, the actual hardware on Mars, was running on a super predictable real-time system, and its brain was programmed in C++. It needed that raw speed and direct control the skeptics talked about. However, the software back on Earth at NASA, the tool scientists used to see the photos, analyze the data, and plan the rover's next moves, that was built with Java. Why? Because it needed to be portable, easy to update, and great at showing all that data.
And guess who confirmed this? None other than Tony Hill, one of the key voices from that original debate. He eventually chimed in to clarify that, yeah, Java was absolutely critical to the mission, but its job was here on Earth, helping scientists make sense of everything Spirit sent back. It was a classic case of using the right tool for the right job.
So what's the big takeaway from this whole story? Well, it's a fascinating paradox, really. The very things that made Java the wrong choice for driving the rover, its built-in safety features, its distance from the raw computer hardware, are the exact same things that made it the perfect choice for almost everything else, and turned it into one of the most popular programming languages of all time.
You see, a big part of Java's genius wasn't just about the features its creators added, but about the complicated things they bravely decided to leave out. They got rid of some of the most common sources of bugs found in older languages. They automated memory management with that garbage collector we talked about. They basically made programming simpler by removing the most dangerous traps. The goal was clear: make it safe and reliable by subtracting complexity. So, to wrap it all up, Java gets its run-anywhere power from the JVM. It's built from the ground up to be safe and simple, even if that means giving up some low-level control. And while it might not be the tool you'd use to drive a rover on Mars, it's the perfect tool for millions of other things. The core ideas behind that 2004 debate are just as important today when you're picking the right tool for your own project.
And that leaves us with one last thought. This story isn't really about which language is better or worse. It's about understanding a tool's strengths. So now that you see how Java's focus on safety and portability has shaped so much of our world, the real question is, what kind of problem could you solve with it?